Very much. Good afternoon, everybody. I would like to first off thank the organizers of Open Data Science Conference for making the grievous error of inviting me to come speak to you today. I got it. Thank you. And okay, so my talk today is about Apache Zeppelin and Apache Drill, and the talk is titled Two Promising Tools Which You've Probably Never Heard of. So I'm just curious, how many people have heard of Drill? Okay, so why are you here? And Zeppelin, who's heard of that? Are you guys users of said tools, or just kind of heard of them and wanted to hear more? Okay, all right, cool. So hopefully you'll get something out of this. My goal for today is basically not to make you expert users of these tools, but just kind of to give you a broad overview of what they're capable of, and hopefully get you inspired to kind of either join the user community or start messing with them yourself and see what you can do with them. So my game plan, again, I'm going to introduce myself really quickly, and then we'll get into Drill and Zeppelin. Now, before I do that, I guess, let me just say that I got particularly intrigued with both of these tools because I see them as helping to solve one of the perennial problems in the data science world. And I'm just curious also, like, how many people would call themselves data scientists or analysts or work in that realm? Is that most people here? Okay, so of you guys, how many of you, your data just flows into your hands or into your computer and it's pristine and it's beautiful and there's no preparation needed? All right. All right. You hiring? No. And I would then ask, well, how many of you then, how your data just no problems visualizing it and presenting it and so forth. So Drill and Zeppelin, in my opinion, are two promising tools that can really help address both of those issues. Study after study show that data scientists spend somewhere between 50 and 90% of their time essentially preparing data or being data janitors. I don't know, does that ring true to everybody? I know it certainly does with me. So I see enormous potential in these tools. So with that in mind, I'll give you a brief overview. I was originally from New York. I went to the University of Arizona, got a degree in computer science there. I went to Brandeis, studied Middle Eastern studies there. I thought it was kind of amusing how I was billed as a former CIA analyst, which is true, but I worked at CIA as a counterterrorism analyst for 5 years, and while it was a great job, the commute really sucked. So I left the agency and joined Booz Allen Hamilton, where I've worked for the last 5 years doing various data science, data analytics stuff for different clients, and most recently I've been doing a lot of data science training and things like that. And then my spare time, I do British sports cars, play trombone, and most recently we had a new addition to our family, which kind of sucked up all of my spare time and sleep. So, in any event, okay, so I'll get to it. My clicker works. Okay, Drill and, no, don't do that. Okay, all right, Drill and Zeppelin. So again, I only have a half hour to speak to you today, and so my goal here is to just give you the broad overview of these two tools. I'm going to approach this from the perspective of a user of these tools and not as like a systems architect or anything like that. So hopefully this will line up with what you guys, with the audience here. And I have no real financial interest in these tools, so if you use them, great. If not, great. This isn't a sales pitch. So in any event, let's start with Drill. So what is Apache Drill? In a nutshell, Drill is the first schema-free SQL engine. Why is my clicker not working? Okay, so traditionally, SQL is kind of has been associated with databases in which they have very rigid schema, and if you were going to put data into it, you have to define, fields very precisely, and that schema cannot change. And if it does change, it's a whole big process to do so. Now, most recently, we have some other, in the database world, that's referred to as the schema on write model. In recent times, we've seen a number of products such as HIVE come into existence where they implement a schema on read system. But Drill kind of bypasses that whole process and allows you to use SQL, standard SQL, to query data without having any defined schema at all. And what's even cooler is that schema, you can give it data, and that schema can be inconsistent within the data that it has, I mean, within reason, but it can be. Drill allows you to query what they define as self-describing data wherever it is using ANSI standard SQL. And so let me kind of just talk a little bit about that. So what that means is that any kind of data that you have that has some sort of defined structure, you can query with Drill. So that would be like CSV files, relational databases, JSON files. Pretty much, if it has structure, you can query it with Drill. One of the things I'm actually really excited about, it's not released yet, but it's going to be in a forthcoming version of Drill, is that Drill will have the ability to query web server logs. And so the ability to write SQL queries on web server logs wherever they are is a very powerful feature. Could really, in my opinion, change the whole cybersecurity realm. And so you notice there, the other two components of this are the wherever it is and then the music standard SQL. So wherever it is, meaning that you don't have to move the data anywhere. You can put a process on a data source, and then that process will communicate with the Drill client, and then you can just type in essentially standard SQL or almost standard SQL, and then you can query your data and join it and merge it and aggregate it and do all those wonderful things. So that's kind of the power of Drill. Am I exciting anyone in this? Is it seemingly interesting? Okay, good. All right, but wait, there's more. We're at Open Data Science Conference, right? So Drill is an open source product. It's not owned by anybody. It was, MapR was like one of the primary backers of Drill. It's since the guy, from what I understand, the development team from MapR, they started a startup like maybe a few months ago called Dremio. But I think MapR is still backing it, and so is Hortonworks. So it has some pretty powerful backers behind it. It's really new, and the first stable version was released around July of this year, so that was version 1.0, I think July or May, sometime around then. And we're up to version 1.2 right now. So it's still I want to really emphasize that it is a very young tool. Drill is flexible and extensible, and what I mean by that is that it is built with a very modular design. So it has interfaces whereby if you have some other data structure or data source that you want to get Drill to read from, you can implement this. You can implement the code that follows their interface, and then you can write your own interfaces effectively that will pull data from wherever. It will allow you to write your own user-defined functions to analyze it, to stick in SQL queries if you so desire. So it's really it has a lot of extensibility. Right now, Drill will. Sorry, my clicker keeps advancing more than I want it to. Right now, Drill can read from Hadoop clusters. It can read from NoSQL sources like MongoDB or HBase. It can read from cloud storage, S3, Azure, Google Cloud Storage. It can read from relational databases. So if you have data that happens to be in a relational database, it can read from that. It can read from file systems. And I think that is not an exhaustive list, but that's all the ones that I came up with. And what's most important is that it can join all these data sources together. Drill is meant to scale, and I have not personally tried this, but yet I'm working on this. But it's intended to be able to execute low latency queries across thousands of servers. The stated goal is to be able to do that across 10,000 servers, and I think the developers have claimed that they've done it with I think 1,000, up to 1,000 servers. I don't have 1,000 servers that I can play with yet, so I haven't done that yet, but I'm working on a project where we're going to see how well that works. So I want to kind of tell a little bit of a story of how I got into this. I gave a presentation a little while ago at Strata where I was looking at data that was gathered from home automation devices, and I wanted to kind of do some analysis on it to see what you could find in that data. And so I had a whole bunch of these devices, and they would pull back data in a whole variety of formats, JSON, CSV, a bunch of stuff. And this was, this was an after-hours project for me, and as I mentioned before, we had a baby, and so it wasn't like I had a lot of time on my hands. So I was finding that it was just a royal, it's not, obviously it's not exceptionally complicated to join CSV and JSON files like that, but if you're kind of pressed for time, it can be. So I wanted to try out Drill and see how well Drill could help me out with doing that. And so what I found was it worked very well for doing that task. And just as a little example here, this is really all it would take to, if you're using drill, to take a data file that's in JSON and merge it with a data file that's in CSV and then aggregate it and do something like that. So if you're comfortable in SQL, it's really easy to do this sort of work without, without having to do a lot of like ETL and other things like that. Now, let me tell you another story. So, and here's where I think that, so just doing that impressed me a lot. But now here's what really what I'm really excited about is, as I mentioned earlier, so I worked up until a little while ago on a metrics dashboard. I've been doing this for like the last 2 years for one of our government clients. And I know it might come as a shock to people that governments, their data isn't perfectly organized and in efficient systems and all that. It's like scattered all over the place. And I'm sure we're not unique in how we did this, but we would have our data, the data is coming from a whole variety of sources, and what we ended up doing was implementing essentially an ETL process that takes data out of their government sources and then puts it into a MySQL database where we can analyze it. And it just, with 1 or 2 data sources, it works. With 20 or 30, it becomes a royal headache, and I end up spending all of my time doing that, which I don't like doing. So, can anyone relate to that, or is that? Okay, so yeah. So what Drill does is Drill can help solve that problem, because instead of having to do this, and instead of having to like spend analyst time, like focusing on that and doing that, what Drill can do is you can install Drill on all of your, let's call them data nodes, and then your Drill client can communicate with that, do all the analysis, and then Drill will output using ODBC or JDBC or RESTful interfaces to your standard BI tool. So I just listed Clicks, Tableau, Python, or Excel. But basically, to these tools, Drill looks like a conventional database, but it's not, in that it's querying all these other data sources and pulling them all together for you. And so, kind of at the heart of Drill, like the way this works is there are these processes which they cleverly call a drill bit. You're not handy, that's a drill bit. Holes and things. And so what you do is that drill bit process gets installed on whatever kind of data node that you have. It could be a Hadoop cluster, it could be MongoDB, again, it could be whatever, it doesn't really matter. And then the drill client will communicate with that drill bit and then execute the queries wherever they need to be. And it's intended to be a distributed system, so it is intended to work with, it is intended to scale. It uses Zookeeper to kind of manage these clusters and do all that. But that's kind of the essence of how that is intended to work. Now, just to give you kind of a sample of how you might actually interact with Drill, it comes with this little sample data set, so I'm going to show you this so you can see it. But this is a notional like employee record data set, and it just has like names and roles and all that stuff. And so you could write an SQL query that looks like this, which gives you a count of all the users per management role. So Drill has a command line interface. So this is the Drill client. Is that quiet? There we go. It has a command line interface, so you can literally just type in your SQL queries there, and it will output them like that. That's one way to interact with Drill. It also has a web interface whereby you can put your queries into the web interface like that, and it can output the results there. The web interface also has some kind of cluster management and performance metrics and stuff like that in there, so you can kind of see how well everything is running. I didn't take screenshots of that, but you can play with that. Now, Drill also, as I mentioned before, it has the ability to work with ODBC and JDBC. So this code right here is code that is Python code that will connect with. It will execute a query on Drill, and then it will pull those results into a Pandas data frame, and then you can have fun with that. So I hope these slides, I'll put these slides up on my slide share, but these are 2 links to Ipython Notebooks, which has code that will enable you to query a Drill with a RESTful interface or with ODBC. I had a lot of problems getting it to work with ODBC, but I think that's my general incompetence in configuring my computer correctly to do that. But I had it working at one point, and the RESTful interface worked a lot better for me. So in any event, there's 2 links so you can do that. Okay, so I'm having a little time here, so I'm going to go a little quick here. So okay, so it's performance. It's meant for low latency queries. It's distributed. Yeah, okay, so I'm going to go a little bit quick through that. Now, Drill often gets lumped into kind of the SQL on Hadoop family of things, and I just want to stress, and it's often kind of compared with HIVE. HIVE is really kind of intended more for like batch processing, and it has this meta store. So Drill does not have that. Drill can actually query HIVE meta stores, and they can interact with each other. But I would stress that they're really intended for 2 different purposes. And Drill really is intended for low latency queries, whereas HIVE, it's not low latency by any means. And table from the Drill documentation. Okay, so you can download it from there. And I'm getting the warning sign, so we're going to move on to Apache Zeppelin. Now, if Drill can get you the data that you want, Zeppelin, what I think Zeppelin can really help do is it can help you visualize and present the data that you've gathered. I have to say I question the wisdom of choosing a name for a project that, when you think of it, I think of a fiery ball, but in any event, Zeppelin's a web-based notebook similar to like Ipython or Jupyter or something like that enables you to create like interactive data analytics. And it is integrated with Apache Spark. And, oops, I apologize. It is integrated with Apache Spark natively, and it does support, like Drill, it's meant to work with, to pull data from a wide variety of data sources. So it can get data easily from Spark, it can get data from Cassandra, let's see, I have my whole geode, Flink, Ignite, PostgreSQL, HIVE, and it can get data from a lot of sources. Now, noticeably absent from that list is unfortunately Apache Drill, but it's being worked on right now, and there isn't also a generic like ODBC database connector for Zeppelin, which I hope someone will tackle. But in any event, it makes getting data and exploring data very, very easy. So let me kind of just show you what it looks like. So this is dang it. Sorry. All right. Time for me to invest in it. Buy a better clicker. So this is what Zeppelin notebook would look like, and you can reconfigure it. You can actually like turn the source code on and off, or the visualizations on or off. So you can make a presentable page that could actually be given to somebody who's just going to look at this data and make some decision from it. But in any event, the top part here, what you do is you first load your data into either a Spark context or to whatever, and then at that point you just run SQL queries on it, and it will generate these visuals below. So there was some Spark code that I apologize. There is some Scala code that just pulls some sample data in and puts it into a data frame. And then from here, all you have to do is you type in a simple SQL query. The only addition you have to make is right here, which tells Zeppelin what language you're using in order to execute this query. And then what this will do is this will put this little window into your notebook. And you can see right there at the top there, we have a couple of different choices of how you want to visualize that data. So you can click on the pie chart, and it will do that. It has nice mouse overs as well, so you can move the mouse over and actually see what data is underlying that pie slice. It can do bar charts. It can interact. One of the problems I've found when doing more advanced interactive data visualizations, the roadblock you eventually run into is either you have to learn JavaScript or you have to spend a lot of money on some BI tool or something like that. And so what Zeppelin can help you do is kind of avoid that issue. And so you can, in addition to just having the static visualizations like that, you can also do some pretty cool, it will enable you to produce a little bit more sophisticated ones by dragging and dropping aggregations in there. So this query, it's aggregated by 2 different columns, and so you can see here this will produce this nice chart, or you can write a stack bar chart. And the bottom line is there's really no coding involved in creating this. And here you can also insert fields where like an end user could type in their own values. So in this case, what it does is there's a minimum and a maximum age field for this query. And so you set a default value, and then what that does is it inserts fields here at the top of your visual where an end user can just type those in, and the graphic will be redrawn on the fly when those values are modified. And you can do drop-down lists. And so you can see there that produces this little drop-down list up there, and you can change that, and the graph will be redrawn on the fly. And that's where you can get Zeppelin. Zeppelin, as you can see there, is currently in the Apache incubator stage, so it's even at a more earlier developed state of development, less mature state of development than Drill, but it really looks like an exciting product, and I hope that after seeing this, some of you guys will be inspired to try it out and see what you can do with it, and perhaps contribute to the development of it. So with that, I guess thank you very much. My time is up. Do I have time for questions? Okay. Are there any questions? Sir?
What are your experiences with performance of Drill? Like, how big can I handle these files? Like, how much data can I handle? And also, the second question is Zeppelin versus Tableau. What's your opinion on this?
So Zeppelin is nowhere near as capable of as Tableau. Where I see the real value in Zeppelin is if I have a client that just doesn't have the budget for Tableau, and a lot of the government work that I do, it's they don't like sharing, they're putting their data on public networks, so you can't use the free versions of Tableau. So they either have to cough up money or they have to find something else. So that's kind of where I see the potential value in it. You asked about the performance. I haven't tried like really massive files on it. I've tried kind of local files, 10, 100 megs, stuff like that. It can query those in under a second, and so I would say it's comparable to a slow database, if that makes sense. I haven't done it in full-on distributed mode on like good hardware. I'm planning a project now where I really want to do that. So I guess to be continued. Anything else? Sir?
You mentioned a forthcoming release with Analytic query web server logs. Is that still structured data like JSON versus like unstructured application logs?
So web server logs are really ugly in how they're formatted, and there is an actual standard for it. It's not like the HTTPD. They don't format it in like JSON or CSV. It's like stuff is formatted with spaces, but the fields are delimited with spaces, but some of the fields have spaces in them, and so it gets really ugly really quickly. And it's not something where you can just say break up this string by a space or break it up by some character. So, and the other thing they're going to do is they will assign all the fields names as well. So you'll be able to just say like show me IPs, or show me incoming IPs and timestamps, something like that. All right. Thank you very much.